since that last Apollo mission over 50 years ago, not only have they not sent another human being to the moon, but we haven't even had another human being leave low Earth orbit, which is pretty much still staying within Earth's atmosphere, staying within Earth's gravitational pull. In the last 50 plus years, we have not had another human being go beyond that. And so you got a question, why is that? Well, all of the astronauts, astrophysicists, people working in aerospace today are saying that the reason they have not left Earth orbit in the last 50 years is because they have not quite yet figured out how to safely get human beings beyond the Van Allen radiation belts. And of course, the Van Allen radiation belts are pretty much what it sounds like. These bands of highly active radiation that literally surround the Earth. And supposedly the higher you go up into these belts, the more intense the radiation gets. And they're saying that fully understanding how these belts work and how they would affect human beings is what is preventing them from leaving Earth orbit. Now, the thing is, they did discover the Van Allen belts about 5 years prior to the first manned Apollo mission. But the thing is, they didn't even really understand the belts then.
This is the first weather image ever transmitted from a satellite. Recorded by a scanning device in Explorer 6, orbiting 17,000 miles above Earth. It indicated cloud cover over a broad area in the Central Pacific. This technique will permit man to track and predict the movement of great destructive storms. Satellites also tell man about strange forces and events in space. In the course of probing cosmic rays, American satellites made possible the most significant finding of the space age, the discovery of the vast and complex regions called the Van Allen radiation belts. Below about 400 miles, the first and third American satellites found the amount of cosmic radiation that scientists expected. But farther out, the satellites found radiation so intense that their Geiger counters were temporarily saturated. Measurements by a later satellite showed no tapering off as far out as 1,400 miles. Instead, the radiation seemed to double in intensity every 60 miles of altitude. Late in 1958, space probe Pioneer 3 reached out 66,000 miles and recorded two peaks in radiation intensity, one at 2,000 and another at 10,000 miles. Pioneer 3 also traced out the outer region of the radiation. These findings led scientists to believe that two great zones of radiation encircled the Earth under the influence of the Earth's magnetic field. Space probe Pioneer 4 confirmed these findings and recorded fluctuations in the farthest regions of the outer zone. New details are being added to the picture of this highly complex region that surrounds our planet. Its discovery is a most important step in sounding the endless sea of space.
So yeah, when they first discovered these belts, all they really knew was the further you ascended away from Earth's atmosphere, the more intense this radiation would seem to get. And it seemed like there was two layers to this thing because the level going higher up was way more intense than the one at the start. And so they figured it must be two separate belts of radiation creating this thing. But again, they could only study it but so far because the Geiger counters couldn't even handle the amount of radiation that they started to experience as you kept going further and further into this thing. And so these radiation belts were mostly still a mystery. And it wasn't until 50 years later when they were able to launch the Van Allen probes even higher into the belts that they realized there wasn't just two belts making this thing up, but actually three belts. And that third belt was even more lethal and even more saturated in radiation than the second. And even then, they still didn't have a clear understanding of this thing, because another 7 years after that, they realized that this thing didn't just have one belt, two belts, or even three belts, but that this impenetrable barrier was actually made up of four belts. And again, that the highest belt that fourth belt had even more intense and more deadly radiation than the rest. And they're still perplexed by this thing. They still haven't gained a true understanding of how this thing works, or how to properly shield human beings or anything organic from it. But again, apparently they were able to get human beings beyond these radiation belts over 50 years ago. And you got so many astronauts, astrophysicists, people working in aeronautics and in aerospace saying the same thing over and over again, that they cannot figure out how to safely get human beings beyond the Van Allen radiation belts. And that because they cannot figure that out, no human being is going anywhere beyond Earth orbit.
The Human Research Program works to project, assess, and solve the problems that astronauts have in space. Specifically for radiation research, the Human Research Program works to predict and mitigate the health effects of space radiation on astronauts.
There's two parts of radiation we have to protect the crew from. One is a solar particle event, where there's a solar storm and these energetic particles stream out. Fortunately, we know how to protect the crew from that. We put them into a shelter that's shielded by lots of water. And actually, they're very short duration, hours to days at most. They can come out and continue with their journey. That's the one aspect of radiation we know how to protect against. The other, which we really don't have a firm handle on, is galactic, cosmic rays. These are highly energetic particles that come from all over the galaxy towards the solar system and Earth. You can't shield against these. They're so energetic, they rip right through all metals, all plastic, all water, and all cellular material. And as they rip through these materials, little electrons and protons pull off of them, and you end up getting a cascade effect of radiation throughout the materials. And sometimes going through certain materials causes a worse radiation environment for the crew that had gone through other materials.
The effects of long duration missions on humans, it depends on obviously how long these are. Right now, NASA considers long duration missions are about 6 months on the International Space Station. Because we're in low Earth orbit on the International Space Station, and we're not going near the poles, the radiation is a concern, but it's not what I would consider life-threatening concern. You do get a higher dose than if you were here on the ground, but from a significant point of view, I think a astronaut can basically do at least 2 missions before there's any concern of saying, hey, do you think they've received too much radiation during their lifetime? And of course, we know that radiation basically can cause cancer if exposed to it too much. And so those are the concerns that we have as scientists. Now, the big thing is, or the bigger concern is, when we go beyond low Earth orbit. In other words, we say, okay, now we're gonna go ahead and go to the moon for a long duration, or we're gonna go to Mars for a long duration. Now we don't have the protection of the poles, because most of the radiation that approaches the planet, because of the poles, gravitate to the poles. And so around the equator, there's not that much of a concern. Now when you go beyond low Earth orbit, now you're more susceptible to getting high energy radiation as a dose to the individual. And so those are the type of technologies that we need to start developing that protects our astronauts from receiving these high doses of radiation once we're out of the confines of low Earth orbit.
But with our appetite for space travel increasing by the day, the problems will continue well into the future.
Radiation is a big threat, and it's the #1 threat, in my view, to humans flying in space.
Around the corner from Frenchies, Dr. Zarana Patel recreates these harmful space radiation environments in this facility and can see exactly the impact the radiation has on the human body.
We are collecting blood samples from the astronauts before sometimes during and then after their flight, and quantifying their DNA damage.
The damage caused by just a single particle of radiation can be lethal to body cells.
It is powered with enough velocity and enough energy to go straight through your DNA.
As a particle hits our DNA, it can rip apart the chromosomes and change their structure.
So when you have misrepair like this, we won't know that it is repaired adequately, and if it isn't, then you will have long-term impacts and eventually cause initiation, progression of cancer.
Touchdown.
This was the moment NASA astronaut Mark Vande Hei ended his history-making spaceflight.
We're getting people into space for longer and longer periods of time.
He returned from the International Space Station after spending 355 days in space. But it will take nearly 3 times that long to send a person to Mars, exposing them to deep space radiation.
Space radiation is a completely different beast compared to X-rays and gamma rays.
Researchers at UT Health San Antonio are working to find out how space radiation affects the cancer risk of astronauts, especially when it comes to a type of aggressive brain tumor called glioblastoma.
The nuclei of atoms, heavier atoms especially, are dangerous, that are essentially moving at nearly the speed of light, and they're highly penetrating.
In fact, the radiation goes straight through an astronaut's helmet, protective shields, and into their brains.
Astronauts report seeing flashes of light, and those flashes of light are caused by these ions hitting their brain cells.
Dr. Sandeep Burma's team used a particle accelerator to mimic the effects of the radiation in deep space. Preliminary studies in mice show it does trigger tumors.
Even very small doses of space radiation can be very, very carcinogenic.
This doesn't mean we can't travel to Mars. It means we have to find ways to protect the men and women going there.
Which is crazy because we know Apollo 12 happened in 1969, and the Van Allen radiation belts were first discovered in 1958. So that's 11 years of scientists, astrophysicists, engineers, astronomers, any and everybody working in aerospace, being aware of the existence of these belts and knowing that in order to go anywhere beyond low Earth orbit, that you would have to go through these belts. But we know that it is a scientific fact that the Van Allen radiation belts is one of the major great unknowns in space. And we know that even though they discovered them in the late 50s, it took them 50 plus years when they were able to send probes into the Van Allen belts, that they were able to really start understanding just how much of a major role these belts would play on the idea of space travel. And you can even look at the timeline of the studies they were doing with these probes, and you can see how it was just becoming more and more evident of how much we didn't know about the radiation belts, and kind of like this increasing revelation of just how dangerous it would be to actually travel through these belts.
In 2012, scientists will finally be able to study another kind of storm in a hazardous area high above Earth when 2 very tough spacecraft, the radiation belt storm probes, are launched. Highly charged particles in the belts can harm satellites and astronauts.
Scientists want to study the radiation belts because there's a lot that we don't know about how particles and events travel from the sun through the Earth's environment and affect the radiation belts. We also have astronauts that are out in space, and the more we understand about the radiation, the better we can protect those astronauts.
This is a field where we go out there and we're doing things on the cutting edge. We don't necessarily, we don't understand everything. And now we understand more. But if we're ever going to work in space, if we're ever going to harness the things that are out there, we have to understand the environment, because the radiation belts are one of the most hazardous areas that we have in space.
The radiation belt storm probes will help researchers unlock the mysteries of the radiation belts, which were discovered more than half a century ago.
They're home to very intense radiation, both electrons and protons, and when these particles get very energized, they can cause problems for satellites and astronauts.
Particles in the belts are considered radiation because of their very high levels of energy. The levels are so high that these particles can damage any matter they come into contact with.
The inner radiation belt is where the protons are very dominating. And a proton, as you know, has a mass much, much heavier than an electron. It can do a lot more damage. So you really do have to worry about your spacecraft safety in that region.
What fascinates scientists about the belts is that they're dynamic structures.
It changes both their size, it usually makes them very big, it pumps them up, and it makes them very, very energetic.
How do we expect the Van Allen radiation belt particles to change? And because they will change, and therefore they will affect satellites and technologies that they're flying in space and even on the surface of the Earth.
RBSP will let scientists answer questions surrounding the belts that have existed since their discovery more than half a century ago.
The Radiation Belt Storm Probes mission is NASA's mission to study the Earth's Van Allen radiation belts, two invisible regions of highly charged particles in space that surround the Earth. The first use for the data from the mission will be by scientists who attempt to understand the physical processes that are occurring in the radiation belts. They'll use those data to develop models for space weather in the Earth's environment, the hazardous features that surround us. However, the data can also be used by engineers to better design spacecraft. For example, if you know how much radiation is out there, you know how thick to shield your spacecraft with walls of metal. The Earth's radiation belts pose a hazard to astronauts. What we want to do is understand just how much radiation is out there and just where it is, and we can warn astronauts when to be inside and outside their spacecraft.
The Van Allen probes have really provided us with more than 6 years of non-stop excitement, continually bringing us wonderful science results, incredible observations from the heart of the most intense radiation region that really humanity has ever found. But they are very, very susceptible to changes in the solar wind. So spacecraft that aren't normally in them can suddenly become engulfed by them. And so it's really critical for us that we understand how these radiation belts are changing so we can better design spacecraft to be able to withstand unexpected dosage of radiation.
So understanding the fundamental science is absolutely required in order to make predictive model relevant to space weather.
We have this highly elliptic orbit in order for the spacecraft to go through all of the different areas of the Van Allen radiation belts. So it really gets a great picture for the scientists of what's going on in the different regions.
The Van Allen radiation belt probes have really shown us just how dynamic and how exciting this region of space is.
Our mission turned it completely around and made it into a complete new science exploration, vibrant field by making a number of unexpected scientific discoveries.
We actually launched them. We really thought they were just two belts. Very soon after we'd launched, we discovered that the outer belt can actually split and form two belts itself, giving us a three-belt structure. But we were able to really watch how that third belt formed.
We not only downloaded every day 3 times more than the science data that we were required to our scientists, we published about 560 papers across the globe.
Right now, every 3 days, someone in the world is publishing a paper based on the Van Allen probes data.
The fact that the spacecraft and those instruments have survived more than 6 years in really what is the most intense radiation region that we know is just incredible.
This mission was about resiliency in the harshest environment that no other spacecraft was able to take. This mission was making the impossible possible, and we really couldn't be more proud of what we've accomplished.
We've always known that there are waves and magnetic and electric fluctuations that go on in these belts. Now with the 2 spacecraft and also the most sophisticated instruments that we've flown in the belts, we're actually able to look at how these waves evolve, how they change, and how long they last. Every single day we're seeing new and exciting data coming in. We're learning much more about the dynamics and the evolution of the radiation belts, why they're changing, how they're changing. We've seen new belts that we didn't even know exist appear. We were able to see a lot of very, very interesting science that we wouldn't have seen if we hadn't had this large event, and we certainly would never have seen it without the tremendous instrumentation on the 2 spacecraft.
So yeah, even before sending these probes in, they already knew that this radiation was a huge hazard to astronauts, spacecraft, pretty much anything that you sent through them. But once they sent the probes in, they realized that these things were even more lethal than they had originally thought, and that this thing was expanding out way further than they originally thought it was. Because the further they would send these probes into it, they would find more belts of radiation. And each belt would be more intense than the last one. And for them, it was like mind-blowing that the probes that they sent in lasted even as long as they did in this radiation. And once the last probe shut down and the mission was over, they still hadn't grasped a full understanding of the radiation belts. And they're still left with a bunch of unanswered questions about exactly how the belts work. But ultimately, they concluded that these belts are way more dynamic and thus way more dangerous than previously believed. And the hazard that they pose to astronauts and spacecraft is extremely lethal, and that scientists and engineers would need to use the data of the radiation gathered from the probes in order to build spacesuits, spacecraft, and other technologies to help to try to ensure that astronauts could safely navigate through this radiation. But again, we've got a massive contradiction here, because we've got the Apollo astronauts saying that they went through this radiation a combined 12 times and saying that the radiation was harmless. It's kind of like we made it to a crossroad, because we've got no technology left from Apollo, no data from the spacecraft, no telemetry data, and the only eyewitnesses, the only people that were physically there to personally witness this trip in space to the moon and back are the 24 astronauts that made this trip. They are the only true reliable source, because they are the only true eyewitnesses. And we've got these astronauts saying that the Van Allen radiation belts were not an issue at all. But then we've got all these scientists, engineers, physicists saying that the Van Allen radiation belts are the most lethal aspect of space, and that we have to first understand this aspect of space before we can even think about sending human beings through this aspect of space. And so really it comes down to, are we going to believe these 24 men who say they safely made it through this thing 12 times back to back without having any effects from the radiation on their bodies and no effects from the radiation on the spacecraft? No malfunctions, no meltdowns, 12 straight times going through this radiation. Or are we going to believe the hundreds of thousands of scientists, engineers, physicists, all saying that the radiation belts are just too complex to send anything organic through without having a full understanding of these belts? Which is why nothing organic has gone through these belts in over 50 years. And why every single astronaut since Apollo has not gone anywhere beyond low Earth orbit. And if you go that route, you got to question, if we can't do it right now, then how did we do it 50 years ago with a lot less understanding of the radiation belts and with heavily antiquated 1960s technology? And we know they can't go anywhere beyond low Earth orbit right now. And so many things point to them having never gone beyond low Earth orbit, either in the past up until today. Like we hear from so many people working in aeronautics and aerospace today, the Van Allen radiation belts, that impenetrable barrier in space, is the number one obstacle between sending organic life beyond the Earth into outer space or staying right where we've been for the last 50 plus years in low Earth orbit, orbiting within Earth's gravitational field. And we know that even after they sent the Van Allen probes into the belts, they still came out of the other end of that perplexed by just how dynamic and complex these belts actually are. And remember how they first discovered the belts? When they sent up the Explorer 1 satellite in 1958. That's when they first detected that deadly radiation. And Explorer 1 was actually launched in February of 1958. And just 6 months later, in August of 1958, 6 months after detecting the belts, they launched Operation Argus, which was at the time a secret military operation where they were conducting high atmosphere tests with nuclear missiles by literally launching them into space. And by the end of Project Argus, they had shot 3 separate atomic bombs into space. And each of these bombs were detonated about 300 miles above the Earth, with the blast radius reaching about 4,000 miles up. And one of the main objectives of this was to specifically try to manipulate the Van Allen radiation belts.
Aboard the guided missile ship Norton Sound, the Viking rocket is ready for firing. The place, the South Atlantic. The time, last fall. This may have been one of the 3 rockets fired by the vessel about that time to explode nuclear bombs 300 miles high as part of Project Argus, the greatest scientific experiment ever conducted. The nuclear bursts in the vacuum of space threw a shell of radiation around the Earth within an hour. A globe-girdling network of thousands of scientists made observations. To monitor the radiation shell in outer space, the satellite Explorer 4 was launched, and all this in a secrecy not broken for 6 months. Most of the results are still not known. But it was a major breakthrough both for purely theoretical science and for military planners, hinting the possibility of throwing up a shield of radiation as a part of an anti-missile defense. In its vast scope and in its enormous accomplishments, Project Argus won proud new laurels for American science.
Now, again, this whole thing was supposed to be kept under wraps. This was supposed to be a secret military operation. But when you're shooting missiles into the sky and literally setting off bombs into space, it's going to be kind of difficult to cover that up. And so eventually this thing did get leaked. And they had to give the general public an explanation of why they were shooting these bombs up into space. And so the official story was that these bombs were detonated to test out a military strategy of creating a radiation shield to defend against enemy nuclear missile strikes. So basically the idea was to detonate these nuclear bombs into space to create this blanket of radiation that would potentially knock out any enemy nukes sent through the atmosphere. And, you know, once Argus got leaked, they got pretty bold with it and they started disclosing all the rest of this nuclear testing. And they just continued firing off these nukes at low altitudes, setting these things off over and over again, all the way up until 4 years later in 1962, when they launched another set of high atmospheric bombs called Operation Dominic. And this one was launched over 2,500 miles into space. And it was the only U.S. ballistic missile ever shot with a live warhead. And literally just 1 month later, they set off a series of 10 back-to-back nuclear launches into space, where at one point they launched over 27 rockets into space at once. And this particular set of tests was called Operation Fishbowl. And at this point, because they were launching so many nukes into space at such high altitudes, you know, nobody was buying the story anymore that this was about creating some type of barrier against enemy missiles. The public was no longer buying it. And so eventually they just came out and said, we are launching these nukes into space specifically to bomb the Van Allen radiation belt and to ultimately try to destroy the Van Allen radiation belt. Now, you got to understand just how many failures and malfunctions they encountered with Operation Fishbowl. Now, remember, they had 4 successful high atmosphere tests before this. But with Operation Fishbowl, right at the beginning of the very first planned test, as soon as they launched the missile, the radar tracking system malfunctioned and they lost the trajectory of the missile and they had to cancel the launch. And then with the second planned test, they launched the missile It flew on a normal trajectory for about 59 seconds. Then all of a sudden, the rocket engine just stopped and the entire missile began to fall apart. And so, of course, this second test was also canceled. Now, for the third test, this is when they launched the 27 rockets, which at this point, you're kind of starting to see the desperation. So, sending up 27 rockets, a broken clock is bound to be right at least once. So this third launch was successful, at least in getting the bombs to detonate in space. But these 27 missiles knocked out over 300 streetlights, took out an entire telephone company link, set off a bunch of burglar alarms, but did not even send a wave through the Van Allen radiation belts. So they went for a fourth launch. And this time, before the rocket could even leave the ground, one of the valves in the engine malfunctioned. The engine started leaking fluid. And again, before this thing could even leave the ground, it caught on fire and burst into flames, which completely destroyed the missile and canceled this launch. So they tried again. And this time the rocket launch was successful. But as this rocket was flying through the air, about 86 seconds in, the rocket boosters just completely failed. And the rocket started tumbling back toward the Earth, which forced them to have to destroy the rocket and cancel this test. But they didn't stop. They just kept shooting these nukes up. And they ended up shooting another 4 nukes into space until that fourth shot, which ended up being the final high altitude shot, and coincidentally was the lowest altitude detonation of any of the other Operation Fishbowl launches. This one was only launched 13 miles into the air. And again, right after they launched this last shot, all high altitude nuclear testing was suddenly just aborted. We have not had another high atmosphere nuclear test since. And just a little bit after this, the Nuclear Space Ban Treaty was formed, which literally prevented any country from shooting nuclear missiles into the atmosphere. Because it wasn't just the US that was shooting up these missiles into space. Pretty much every single country that had developed nuclear missiles was sending these nuclear missiles into space. The Soviet Union, Russia, China, France, all these different countries were shooting these nukes up into space all around the same time. And again, they all simultaneously stopped around the same time. And then the Nuclear Space Ban is formed, which is basically all of these countries agreeing to never shoot another nuke anywhere near space ever again.
Meanwhile, the foreign minister presided at the signing of the treaty banning nuclear weapons from outer space. He pledged Britain's wholehearted support. Without such a treaty, life on Earth would be under continual threat, a nightmare existence. Soviet Ambassador Smirnovsky acted for Moscow. On the right sat the American chargé d'affaires. Other signings were made in Washington and Moscow. So far, 31 nations have joined in the treaty. The Russian ambassador. Philip Kaiser for America. Between West and East, this is the best cooperation for a long time.
Now, if you look at the different names of these operations where they were launching these nukes into space, this is where it gets really interesting, because remember the name of that very first high altitude nuclear test? Argus. Well, that name, Argus, is actually the name of a Greek god. And Argus was actually a giant god with multiple eyes. He actually had over 100 eyes. And in the mythology, he would mount himself on top of the highest mountain. And from that mountain, he was able to use those eyes to see everything. And so essentially, Argus was an all-seeing god. And then remember what preceded Operation Argus? Operation Dominic. And if you look up the name Dominic, you're going to see that it means of the Lord. or belonging to the Lord, or literally belonging to God. And then right after that, underneath the umbrella of Operation Dominic, we got Operation Fishbowl. And again, Operation Fishbowl was conducted under the umbrella of Operation Dominic. So you could literally look at it as an operation with the sole focus being on the fishbowl of the Lord, or the fishbowl of God. Because think about the idea of a fishbowl, where you got those fish contained inside that isolated environment, and they're contained inside that environment that they have to remain in. Because if they go outside that environment, they will die. You know, it's a special environment specifically made for them. But even within that fishbowl, those fish can see that there's a much larger and much more expansive world outside of that fishbowl, a different type of world that they just cannot reach. And of course, outside of that fishbowl, in that world, are the very people responsible for placing them inside that environment, that are able to look over that fishbowl and monitor and see everything going on inside. And again, you got two of these three high altitude detonation operations named Operation Fishbowl and Operation Dominic. And then, of course, again, the very first of these high altitude operations is called Operation Argus, which again is referring to an all-seeing God. And just think about all those malfunctions and failures of those last few rocket launches, of those missiles into space, before they just abruptly stopped and that space ban treaty was formed, and how the very last high altitude nuclear blast was just 13 miles off the ground, the lowest high atmospheric test they have ever done. And then all of a sudden, literally every single country agrees to never shoot another nuke into the atmosphere ever. Now, remember, the whole point of all these high atmosphere nuclear tests, they finally admitted, was to try to destroy the Van Allen radiation belt. And what's interesting is that the very first atmospheric nuclear tests, the first nuclear tests that were conducted above ground, were called Operation Hardtack. And when they first started launching these above ground, they set off more detonations than all of the prior missions for nuclear testing. And again, these first atmospheric tests were called Operation Hardtack. And hardtack is actually this extremely firm, extremely solid bread that used to be used by soldiers and pirates for long missions and, long voyages, because of how long this bread would last. This bread was so hard and so firm that you couldn't just bite into it. You would end up losing some teeth. It was that firm. You had to dip it in something boiling hot just to soften it up just a little bit. And, hardtack was so firm that it actually spawned stories of hardtack being used to even stop bullets. And again, the very first nuclear atmospheric test that would eventually lead to them literally trying to bomb the Van Allen radiation belts was called Operation Hardtack. So basically an operation to get through something impenetrable. And the most interesting part is that the very same year that all of this is going on, the discovery of the radiation belts and the conduction of all these high atmosphere nuclear tests into space, right in the middle of all of this, NASA is formed. And NASA completely takes over the entire United States military space program. So literally anything to do with the exploration of space would begin and end with NASA. And again, NASA is formed just as they discovered the Van Allen radiation belts, and right when they started shooting these nuclear missiles into space, which again, space was now NASA's domain. They now had complete autonomy over anything going on in space pertaining to the US. So it brings up the question, was NASA formed with the primary objective being to try to find a way, any possible way, to break through and get beyond the Van Allen radiation belts, because the timing just seems to line up. And now remember, through Operation Paperclip, you had that Nazi rocket scientist, Werner von Braun, brought in that would eventually take over the ballistic missile program for the United States and ultimately become the director of flight and engineering for NASA. And the question is, did they already know about the radiation belts and how difficult it would be to try to get past these belts? And could they have already been planning to bomb these belts, way in advance before sharing this information with the public? There's some things that point to that, because 3 years before they announced the discovery of the belts, in 1955, there was a press conference led by Werner von Braun called The Challenge of Outer Space, where he was discussing the development of rocket technology that would eventually send human beings into space. And during this press conference, there was 2 separate times where, instead of referring to these things as rockets or spacecraft, von Braun is referring to these objects that they plan on sending into space as missiles.
Gentlemen, will you please take your seats so we can begin today's conference? I take a great deal of pleasure in presenting to you today as our guest speaker, Dr. Werner von Braun. Dr. Braun.
Gentlemen, the conquest of outer space is the greatest technological challenge of the age in which we live. The first decisive step in the conquest of space will be the placing of an object into an orbit wherein it will indefinitely circle the Earth. Let us take a look at our first slide. You see a model of the 3-stage rocket on this picture. Up to this lower white line here is the first stage. It is powered by a number of rocket engines which will lift the missile off the ground until it has reached, after approximately 1 minute operating time, a maximum speed in the order of 3,600 to 4,000 miles per hour. So every time it would go through the perigee, it would lose a little bit of that excess speed, and as a result, the next apogee would be somewhat lower. And this gradual loss in excess speed would gradually lead to a conversion of the elliptic orbit into a circular orbit 60 miles up. And after this has been accomplished, the ship would be subjected to atmospheric drag throughout the entire flight around the Earth, and from then on, of course, it would lose speed rather rapidly. But with the help of the wings, it would be able to land again.
So yeah, was it a slip of the tongue? Who knows? But 2 times during that press conference, he very clearly refers to these things as missiles. And so, that's when you got to start to question, what was the ultimate goal of all this early military planning of space exploration? What was the ultimate goal? To send rockets and manned spacecraft into space, or to send missiles into space? Well, we can definitely look at the timeline and we can see, before they ever sent the first spacecraft into orbit in space, they were sending up ballistic missiles first. Literally, after the Explorer satellite was launched into space, the only other thing they launched into space for 5 years straight were ballistic missiles, nuclear missiles that they were detonating into space. Over 50 missiles, just launching them into the upper atmosphere, back to back. And remember what they coined these first steps toward the exploration of space: the challenge of outer space. And so, you got to look at this and question, what was the real challenge of outer space? Developing the rocket technology to get into outer space, or trying to find a way to get beyond that impenetrable barrier in space? It kind of seems like that would have been the real challenge, and that this is something that they knew was going to be a challenge for a long time. This wasn't something that they just happened to stumble upon in the 50s, because the fact is, the further you dig back into the little bit that we can salvage of human history, the more you're going to see this consistent repetition of this idea that there is some type of barrier in place dividing the earth from what we would consider outer space. When you look back at so many different ancient civilizations, they all seem to in some way reference to some type of barrier keeping the earth separated from whatever is beyond the earth. Of course, we can look back at the Egyptians and those depictions of Nut and Geb. You know, you got Nut, who is the goddess of the sky, and you got Geb, who is the god of the earth. And every time you see a depiction of Nut and Geb, you always see Nut, who again represents the sky, completely encompassing Geb, who again represents the earth. You know, they always show her like enveloped over Geb like a canopy on all the papyrus that they took from Egypt and put in the British Museum. You've got Nut arced over Geb like some type of canopy or some type of covering. And then you have those hieroglyphs on the walls in the Valley of the Kings, in the tomb of Ramses, where you see Nut arc completely over the sky, and you can see her separating the world above, the higher realms, the spiritual world, from the world below, the physical material world, basically life as we know it. You got that depiction of Nut basically being like a physical barrier between these two realms. And then you can see that the only way that people are passing through is on those boats, those solar bards, which is basically saying, you know, the journey beyond this earthly plane is not a physical journey. Then you could look at the Mayans or the Aztecs. You know, you got those ancient Mayan temples over in Mexico, the Bonampak temples, where you've got all those different murals depicting the Aztecs or the Mayans. And within those different murals, you're getting those different layers of existence, you know, from the common folk to the warriors to the royalty. You know, each layer is giving you the hierarchy until you get to the very top, which kind of like has that border around it, separating it from everything below it. And they say for the Mayans, this was supposed to represent the vault of the sky, this great barrier that nothing could break through. And you can see you got the sun god and the moon god guarding that vault in the sky. And you've even got that depiction of some of the people trying to send one of the horses through that vault in the sky. And basically you can see the horse being completely split in half as they try to send this thing through that vault, you know, kind of like showing you that nothing organic can pass through this vault in the sky. And in Hinduism, you got the god Dhruva, basically a representation of Polaris or the pole star. And the idea is that Polaris or this pole star, it creates some type of shield separating the earth from these higher levels of existence. Then you've got the Vedic text, you know, dealing with Hinduism and Buddhism, that describe this thing as being some type of barrier, you know, a barrier between the earth and the higher realms where these higher beings would exist and where you could find these different realms of existence. You see this mentioned more than a few times in the Vedic text, that there is a barrier called the firmament separating the lower realms from the heavens. Then, of course, you've got the Quran, which describes some type of canopy above the earth, a secure canopy that nothing can get through. And you can see this theme of this canopy, this barrier, even in the Bible. It describes a barrier separating the heavens from the earth, a barrier that, just like the Vedic text, is referred to as the firmament, and that this firmament was constructed to divide the heavens from the earth. You see it mentioned in the first chapter of Genesis and through multiple verses throughout the rest of the Bible. And again, this is a constant theme that you see across the board with so many of these ancient civilizations, so much of these ancient writings. You see it over and over again, that there is a barrier in place separating the earth from whatever is outside of it. And what's interesting is that when von Braun passed away, besides his name and the date of his passing, the only other thing on his headstone is one single Bible verse, Psalms 19:1. And when you look at this verse, it literally reads, "The heavens declare the glory of God, and the firmament showeth his handiwork." So literally the only message left on the headstone of the original director of flight and operation for NASA and the one and only rocket scientist credited with the one and only instance of ever getting human beings beyond low Earth orbit is a verse describing an impenetrable barrier between the Earth and space. Now, the Apollo 8 astronauts were supposed to be the very first humans to travel to the moon. And when they got there and they were orbiting around the moon, they actually broadcast this moment on television. And one of the first things that the Apollo 8 astronauts did was send out a message to everybody viewing the broadcast. And as a part of this message, they read from chapter 1 of Genesis. And when you look at the verse that they chose to read, again, this is where it gets interesting.
We are now approaching lunar sunrise, and for all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light. And God saw the light, that it was good, and divided the light from the darkness. And God called the light day, and the darkness he called night. And the evening and the morning were the first day. And God said, "Let there be a firmament in the midst of the waters, and let it divide the waters from the waters." And God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament. And it was so. And God called the firmament heaven. And the evening and the morning were the second day. And God said, "Let the waters under the heaven be gathered together into one place, and let the dry land appear." And it was so. And God called the dry land earth, and the gathering together of the waters called he seas. And God saw that it was good. And from the crew of Apollo 8, we close with good night, good luck, and God bless all of you on the good earth.
So yeah, again, this is where it gets interesting, because as soon as they move into orbit around the moon, they send out this message and they quote from the Bible, and the passage that they choose just so happens to be the very first passage in the Bible that is describing the firmament. So out of all the passages that they could have chosen, from 66 books of the Bible, hundreds of pages, thousands of verses, so many different passages that they could have chosen, and they choose a passage describing a barrier in space. Again, it's interesting. It makes you think, was this some type of cryptic message? Were they subliminally letting us know that they weren't actually orbiting the moon, and that they only got as far as the firmament or the Van Allen radiation belt would allow them to go? It's definitely something that you got to look at and you got to question. And when you start digging into this word firmament, you're going to see that it basically means something strong, steadfast, enduring. And translated from the Greek, it literally means a firm or solid structure. And if you go back far enough into the etymology of the word, it actually stems from the Hebrew word rakia. And when you start digging into this word, you'll see that it's another word that has multiple meanings. It's used to describe a lot of different things, with the main definition being an extended surface or expanse, literally the expanse of heaven, which again is connecting back to the Egyptians and Nut creating that impenetrable arc over the sky, or that secure canopy, that the Quran talks about. So basically this word firmament is kind of encapsulating all these different ideas of this one ultimate concept of this barrier separating Earth from everything outside of it. What's interesting is that less than a century ago, this was a common term. When people working in astronomy, astrophysics, cosmology would make references to space, it was pretty common for them to refer to space as the firmament. Anything beyond the Earth anything pertaining to outer space. On a lot of occasions, they would reference those outer regions as the firmament. And considering what that word firmament is referencing to, some form of a barrier in space, you got to wonder, is that what these early astronomers, astrobiologists, physicists were referring to? And maybe it's just a case that the firmament kind of morphed into the Van Allen radiation belts over time. But when we're talking about the firmament, when we're talking about the Van Allen belts, maybe we're talking about the same phenomena, a phenomena that when you look back at it, they already knew was extremely dangerous and was going to be a hindrance to space travel. And when they first sent the Van Allen probes into the belts, they were already aware that the belts existed, that they were dangerous. They knew that deadly radiation was there, but they didn't know just how deadly it was, how deep it stretched out into space, and how it was actually formed. How did this huge blanket of radiation just form around the entire Earth? And the goal of sending in the probes was to try to get those answers. But you could just see from the moment they sent the probes in, just how baffled these scientists were by these belts, by everything from the insane intensity of the belts down to how it just seemed like the belts had this perfect structure or framework bringing them together. And when you hear how they describe these belts, again, it's as if the firmament was just renamed the Van Allen radiation belts.
I'd like to welcome everybody to the first of 3 oral sessions on the radiation belts and ring current. This session was organized by Mona Kessel, David Sybeck, and myself as a good forum for first results of the Van Allen probes.
Our overarching goal is to understand how these radiation belt particles, why they exist, how they form, the radiation belts form, and how they change. It has very practical applications, space weather, allowing us to design radiation-hardened spacecraft better by improving models. It actually is finally, this is a mission we've been waiting for 50 years. We know what's there, we think we know what's there, now we can really go and measure it. So we'll be resolving the age-old questions.
So this is 3 orders of magnitude of particle variation intensity seen. And on your left, closest to the Earth, obviously, there is the inner zone, and the outer part, I think you can see, but that's the highly dynamic outer belt, the one that we're really concerned about. These are 4 to 5 million electron volt particles. Electrons of that energy can punch through over half an inch of solid aluminum. What we're seeing is a much more dynamic, much more rapidly changing kind of an outer radiation belt than we had really expected to see.
And so we've heard about the dynamics of the outer radiation belt, and we've heard about the wave fields that we think are responsible for a lot of the dynamics that we've seen. But I'm going to talk about this inner green region here, which is called the inner Van Allen belt. And of course, it's the one that actually James Van Allen measured first on Explorer 1. These are high energy protons, and their origin is enigmatic. Their impacts can be very severe depending on how much time a spacecraft spends in that region. Any space vehicle that we send out has to penetrate these regions to get outside of the Earth's gravitational well. The peak intensity is about 6,000 kilometers, and so the 3 vertical bands, the red, black, and the blue, are where we just take samples of what the energy distribution is, and that's what's shown on the right here. And we're seeing protons up to 1 billion electron volts, and these are the highest energy trapped particles in the Earth's magnetosphere. They're very stable. They're there all the time. I can tell you offline as to what we think the theoretical origin is. It's too complicated to get into now, but it's important for many reasons.
This is 24 hours worth of data. We see very, very powerful waves that exceed 20 millivolts per meter. These are saturated up to 100 millivolts per meter on this particular scale. And we see them for hours and hours and hours. And one spacecraft will rotate out of position at apogee, and the other spacecraft will rotate, and we'll continue to see these waves. And so there you see it, very powerful Whistler waves right down at the radiation belts. And we're seeing them for hours. This is a 4-hour period, and there's just a blizzard of high amplitude Whistler waves that are being monitored here, hundreds of them.
This mission is back to the future for me.
We've had very few equatorial missions studying the Earth's magnetosphere. The importance is that the ring current and the plasmasphere forms all kinds of wave activity, which can interact with the drifting particles, can cause them to be accelerated and moved around in the Earth's magnetosphere, which can cause the acceleration of electrons in the Earth's radiation belt. Very little of this work has followed on the last 30 or 40 years. Really interesting. And now we have an opportunity with our BSP to explore this in much more depth and detail.
It's these structures that I want to discuss because they're really quite interesting. You wonder why nature produces things in such a nice, organized way. This is another example going through the center of the magnetic anomaly. In this region, the Demeter spectrometer is saturated, so it doesn't see very much, but after you go out of the anomaly, then you see another series of peaks. This indicates the location of the peaks. Sometimes this peak to valley ratio gets as high as 10. So they're really quite interesting, and one has the feeling that nature is trying to tell us something if we're just smart enough to see it.
So the data that they were getting from these probes was just blowing them away. You know, again, they knew the radiation in the belts was intense, but then they get this data back and they can see that just the inner belt alone is reaching up to over 1 billion electron volts. And that's just the inner belt, the section of the belts that's closest to the Earth. But as the probes continued to move into the outer belts, the further and further up they went, the more and more saturated the spectrometers were with radiation, to the point where they could no longer get any readings on this radiation. But you can just imagine if the inner belt is reaching over 1 billion electron volts, then the outer regions of the radiation belt just have to be insane. You know, it's so intense that it's not even being picked up by a spectrometer. And we already know the higher you get into the belts, the more intense the radiation gets. Those numbers just keep rising. So again, we can only imagine the amount of insane radiation that we're dealing with. And these probes lasted for about 7 years in the belts. And of course, within those 7 years, they continued to pick up new data relating to the belts. And one of the most perplexing things that they monitored was just how uniform and stable the electrons were that made up the belts. You know, they were coming together to form these belts, but it was like something literally bringing them together and basically trapping these electrons to form these bands that surround the Earth. You know, literally forcing these electrons to group together in a perfect stabilized band that's just set in place in its position just above the Earth. And the question was, how is this happening? How are these highly charged electrons that, you know, essentially should be going all over the place, being forced into this fixed, stable structure? And what they found was that deep in the outer region of the radiation belt, there is what they call a storage ring that is literally, just like it sounds, storing these electrons and protons that make up the radiation belt. They say for what seems like years to decades before eventually shooting them out. You know, it's like this perfect system where you've got this new batch of electrons and protons that sit in this storage ring and just continuously replenish these belts in what seems like this never-ending cycle. And when these protons and electrons shoot out, they're being shot out at these crazy speeds, you know, like close to light speed, which causes them to get excited and accelerate into that insanely potent radiation. And so again, because they're being shot out of this storage ring and pretty much being accelerated, they looked at this data and said, we've literally got some type of particle accelerator within these belts, because there has to be something in the belts accelerating these particles to these insane speeds. But the question was, what is it that's causing this acceleration? And where are these electrons and protons that are entering this storage ring coming from? You know, what is it that's constantly feeding this storage ring and keeping these belts going? And that's when they found the coarse waves. Hundreds and hundreds of Whistler waves constantly moving through these belts and making the belts more dynamic and increasing the frequency of that radiation. And eventually they were able to convert these waves over to a radio frequency. And it's crazy. The sound of these waves in the Van Allen belts. So yeah, on a radio frequency level, this is what they say it sounds like in the belts. And these sounds or frequencies are constantly shifting, constantly changing, because you've constantly got these Whistler waves flowing through these belts, which again, these Whistler waves are making the belts more dynamic and increasing the frequency of that radiation consistently. So essentially you could look at those Whistler waves as another form of particle acceleration, and, you know, like more proof of some type of a acceleration mechanism within these belts. And so, you know, they said we've got the storage rings storing the particles and shooting them out at near light speed. Then we've got these Whistler waves flowing through the belts and increasing the dynamics of the belts. So what we're seeing isn't just some type of particle accelerator. What we've actually got here is like a literal geophysical synchrotron, and the only naturally stable and self-replenishing synchrotron in existence. So then the next question is, what is a synchrotron? And why did they specifically go from referring to this thing as, like a particle accelerator, and specifically go to calling this thing a synchrotron? Well, essentially a synchrotron is a giant sophisticated machine, a giant machine that accelerates electrons to extremely high forms of energy, to extremely fast speeds and extremely high forms of radiation. And to create this radiation, this synchrotron has a storage ring that stores the energy from the electrons and resupplies that energy back into the system. It also has a booster that accelerates the electrons. And then at the end of all that, they're sent through these beam lines where these electrons can be experimented on. And in order to run properly, these machines have to run day and night with very minimal shutdown. The only time they shut these things down is for maintenance. So otherwise, these synchrotrons are running 24/7. And again, they're saying that the only natural phenomena that matches what is going on with these synchrotrons is what is going on inside the Van Allen radiation belts. And what's crazy is that you've got hundreds of these synchrotrons all over the world. And again, they are studying the acceleration of particles in a ring-like form or in a belt-like form.
Located in South Oxfordshire, Diamond Light Source is a new scientific facility called a synchrotron. It is made up of a large donut-shaped building containing the machine and an adjoining office building for the 350 scientists, engineers and support staff. The machine includes 3 particle accelerators, a linear accelerator or LINAC, a booster synchrotron and a storage ring. Let's follow a single bunch of electrons on their journey. In reality, hundreds of electron bunches are travelling around the synchrotron at any one time. A bunch containing billions of electrons is generated in the electron gun and then directed into the 30-metre LINAC. Next, in the booster, which is 158 metres in circumference, they are further energised to nearly the speed of light. The electrons are then injected into the storage ring, a 562-metre circumference machine. When accelerated to just under the speed of light and pass through strong electromagnetic fields, all charged particles will emit electromagnetic rays, the synchrotron light. As the electron particles race around the storage ring, they pass through specially designed magnets. These insertion devices wiggle the electron bunch, producing intensely bright beams of light. The light is transferred into the experimental laboratory or beamline, allowing scientists to learn about their samples in great detail.
So again, you got these synchrotrons all over the world, which are mimicking what is going on in the belts. And they're basically isolating this energy created by these synchrotrons in order to study the energy. So they're studying the energy produced by these synchrotrons, running these things 24/7. While we also have a natural geophysical synchrotron that is in a constant rotation right above us. So the question is, what motivated them to create these synchrotrons? And why are they studying the energy created from these synchrotrons? It seems like they're trying to create the same conditions as the radiation belts. And they're trying to isolate that same energy that you would get from the radiation belts and, maybe ultimately figure out how to shut it down and ultimately do what they weren't able to do with all those high altitude missiles. Because again, you've got hundreds of these synchrotrons all over the world, and they're all a part of the International Atomic Energy Agency, which is a branch of the United Nations. And the International Atomic Energy Agency was founded in 1958. The same exact year that they started shooting these atomic missiles into space. And remember, eventually they let us know they were shooting these missiles into space to try to eliminate the Van Allen radiation belt. They were aiming these missiles straight for the belts. And, considering that there's some type of storage ring that is just continuously replenishing these belts and basically keeping these belts stable. You got to wonder, did they already know about this storage ring back then in 1958? And were they possibly aiming for this storage ring? It is worth questioning because remember, the International Atomic Energy Agency is created in 1958. And the very first synchrotron was built in 1961, 1 year before Operation Dominic and Operation Fishbowl, when they really started letting those nukes off into space, until we finally got that space ban treaty the next year. And every country agrees to completely stop shooting any nukes anywhere near space. And it's almost like a perfect succession because, they're now no longer shooting the nukes directly at the belts. Now they've got a way to harness those accelerated particles, that radiation. So it's almost like they went from aiming those missiles at the belts to studying the inner workings of the belts at ground level. There's something definitely there because all the synchrotron research is being used for space research. And so instead of all these different countries shooting up nukes into space, you now got all these countries running these synchrotrons 24/7. And of course, the most popular synchrotron in the world belongs to Cern, the European Council for Nuclear Research over in Switzerland. They're operating the largest particle accelerator in the world, the Large Hadron Collider. This thing is so large and so powerful that they actually had to build it underground because unlike a lot of these other particle accelerators, Cern is actually accelerating these particles close to light speed and then literally colliding them together, smashing these particles into each other, with the idea being that if you can smash them into smaller components, then you can analyze those smaller components and possibly see the inner workings of these particles, see what is bringing these protons, electrons together and causing them to form. But again, they are probably the largest and most well-known company in possession of a synchrotron. And, Cern is just another example of them using this synchrotron research for underlying space research, because you had Cern publicly sign that cooperation agreement with the European Space Agency. They have that agreement to share all information that comes from their synchrotron research with the European Space Agency. They call it data sharing or data transfer. And pretty much anything they find, they share with ESA. And then, it's well known that they work directly with NASA, specifically for radiation research. And these collaborations have been going on for years. So Cern is heavily involved with these major space agencies, specifically for radiation research. And Cern is so specifically well known because they had the biggest breakthrough of pretty much any of these other organizations that, use these synchrotrons. They dropped like pretty much a bombshell. That year, they announced that they had found the Higgs boson. And the Higgs boson is this particle that's supposed to be responsible for giving every atom its mass. So basically, look at it like the Higgs boson would be like the egg before the chicken. So before you have a proton or electron, any type of particle, you're going to have a Higgs boson first. And the way you could look at it is like these protons, electrons, these different particles basically hatch from the Higgs boson. So without a Higgs boson, you don't have these particles, and these particles don't have any mass, which, that mass, ultimately makes them third dimensional. So, the Higgs boson is kind of like getting close to the genesis of these particles. It's getting real close to their starting point. And because of this, they literally called this thing the God particle. And, Cern was the first to claim that they had found this particle.
As a layman, I would now say, I think we have it. You agree? Yeah. Okay.
Until today, the so-called God particle, the key to our understanding of the universe, existed only in theory, but not anymore. Collecting data like this, scientists at Cern have announced the discovery with 99.999% certainty that the Higgs boson does exist, the so-called God particle. So what is the God particle and just what does it do? Well, in one sense, it is the missing link to this massive equation. This is the standard model for particle physics, and this is our understanding of how the universe works. The Higgs boson gives us mass, which is how we measure matter. So how did scientists find it? Well, with a massive particle collider at Cern, 27 kilometers of tunnels under Switzerland and France. Researchers smashed particle beams together to see what's inside. And this is what they saw. Subatomic debris, including the decayed remains of what they say appears to be the Higgs boson. But the mysteries of the universe are not solved yet. There's still a lot more to discover. Finding the Higgs boson, the God particle, just opens another door.
Now remember, the Higgs boson is like the egg that these different particles hatch from. But the Higgs boson only lasts for less than a trillionth, a billionth of a second. So this thing dissipates faster than the speed of light. Literally, it forms and deforms in less time than it takes light to hit the human eye. So it's like that egg hatches and immediately decays and it's just gone. So you know what they found was signs of the decay of the Higgs boson, but not a full form particle that they could actually isolate. And even the remnants that they found were just from the data, you know, nothing physical, nothing tangible. So it would be like nearly impossible to try to actually isolate this Higgs boson particle. But you got to think, if they could isolate this Higgs boson particle, the very particle that electrons and protons are coming from, and that is giving these particles mass, and try to figure out a way to manipulate it, it could ultimately lead to them being able to do what they wanted to do for a long time, which is completely eliminate these belts. And this is where you got to question the Van Allen probes and the real reasoning as to why they sent those probes into the belts. Because, you know, it's pretty obvious that they were already, you know, very familiar with these belts before they even sent the probes in. So, you know, the question is, what was sending these probes into the belts really about? We did get some really good data, but think about this. CERN announced the discovery of the Higgs boson on July 2012, and the Van Allen probes were launched in August 2012, just 1 month later. So, you know, the idea that these two things are connected, the discovery of the Higgs boson, the God particle, and the launching of the Van Allen probes into the radiation belts, you know, it seems like there definitely could be some type of connection. But again, from what was released, we did get some pretty good data back from these probes. And probably the most interesting aspect of this data is that about 4 years in is when they officially started referring to this thing as an impenetrable barrier. Because, you know, they said the further you get into the outer zones of the radiation belt, the more energized and stable those electrons become. And this is where they said, you know, we're going to have to find new and innovative ways to protect our spacecraft that are going through this region. Because, you know, any spacecraft trying to leave Earth orbit is going to have to go through this region. Because obviously the outer zone is also where that storage ring is located. So you're getting like an insane amount of charged particles just in that region. And again, you know, that was the big question. Where are all of these particles that are filling this storage ring, you know, coming from? You know, they had theories, you know, some of this radiation could be coming from the sun, from solar flares. Quite a bit of it could be cosmic radiation that, you know, moves into our region of space and then finds its way into this storage ring. But they really didn't have an answer, because even if it's cosmic radiation or radiation from the sun, it still doesn't explain just how, you know, almost like calculated the filtering of these particles into this storage ring is, especially the way the particles are being filtered down into the inner belt, you know, almost like a conveyor belt, and literally creating the plasma pulse where, you know, that band of radiation is closest to the Earth. You know, they really didn't have an answer for how this thing functioned, you know, what is actually bringing it together. But one thing that they did find was that in the outermost part of the belt, there is a bubble of electromagnetic energy that is literally encircling the radiation belts and is almost like keeping these belts locked in, almost like a capsule or, some type of shell. And because it's just above the outermost region of the belts, it could actually be looked at as like the fourth and final band making up the radiation belts. And they coined this thing the VLF bubble. VLF standing for very low frequency waves. And they say that this VLF bubble is almost 100% produced by human beings. Because again, they say that all the low frequency waves that we send out into the atmosphere over time created this bubble that is surrounding the belts and, essentially making the belts even stronger. And when you're talking about VLF waves, you're usually talking about waves that come from radio frequencies from submarines or from like long range navigation. But think about it. VLF literally just means very low frequency waves. And remember, all throughout the belts, you have those coarse waves, hundreds and hundreds of Whistler waves that are constantly flowing through these belts at an extremely low frequency. And remember, these waves are exciting those charged particles in the belts and ultimately making the belts more intense. So you would think if there was any low frequency waves that would be powerful enough to create this shell around the radiation belts, then it would be these coarse waves. Because you got to even look at the fact that the highest amount of Whistler waves are in the outer belt, which is the belt that's closest to that VLF bubble. So you got to wonder, are they trying to downplay these Whistler waves by saying this thing was mostly created by human beings? And, if it was created by human beings, is it in the way they're telling us? Because you got to look at the sequence of events. They launch these operations and fire all these nukes directly at the belts. And then years later, they send the probes in and find that a giant shell formed to wrap itself around the entire radiation belt. It kind of sounds like a protective mechanism for the belts, almost like a shield around these belts that, when you look at the data, is completely surrounding the belts, and that they say is just as intense and just as impenetrable as the most intense regions of the belts. They say this bubble holds some of the highest charged particles out of any other area in the belts. But ultimately what they're saying is these belts are extremely intense, extremely dynamic, and that we do not have a full grasp on them, which is why you have so many astronauts, astrophysicists, astrobiologists today saying that the safest place for a human being to be is in low Earth orbit, just like we've been for the last 50 plus years. And, we got so many things pointing to them trying to figure out a way to just completely eliminate these belts.